2, 3. Hi, Assalamualaikum. Our group will be presenting on air freight capacity, specifically how we can forecast it using multiple regression analysis. And I'm Danya. And I'll be starting off us off today and joined by Arisa and also Shami. Next slide. So, air freight capacity refers to how much cargo airlines can actually move within a given period. Unlike passenger demand, it's shaped by several forces at once, not just one. So that's why we use multiple regression. Our models look like this. AFC equals to B beta 0 plus beta for global trade volume plus B beta 2 for fuel price index plus beta 3 for fleet availability rate plus an error term. So each one of these three variables plays a different role. So beta 1 is our demand driver, beta 2 is our cost suppressor, and beta 3 is our supply enabler. And I'll be covering the first variable now. Next slide. So global volume is our primary demand driver and it has a positive relationship with air freight capacity. So simply put, when more goods are moving across borders, airlines respond by adding more flights, opening new routes, and also wet leasing extra freighters. So we saw this very clearly during the post-pandemic e-commerce surge between 2020 and also 2022. So cross-border online shopping exploded, especially shipments from China and Southeast Asia to the US and Europe. So IATA reported that air freight ton kilometers grew over 6% in 2021 alone. So locally, Malaysia Airlines converted A330 passenger jets into cargo planes, and AirAsia's teleport division fast-tracked its dedicated freighters plans to capture that intra-Asian growth. So this is why Beta 1 carries the highest weight in our model. Without cargo demand, there's simply no economic reason to deploy capacity. And now I'll hand it over to Arisa.
Next slide. Next slide, please. Okay, thank you, Dania. I'll be covering our second and third variables. So fuel is the largest operating cost for most airlines, usually around 20 to 30% of total cost, and sometimes even higher for freighter airlines carrying heavy cargo on long distance routes. When fuel prices increase, airlines have to make difficult decisions, absorb the extra cost, charge customers more, or reduce flight operation. This is why beta 2 has a negative coefficient, meaning that higher fuel costs are associated with lower air freight capacity. In simple terms, when fuel cost goes up, capacity tends to go down. A good example is the 2022 fuel crisis following Russia's invasion of Ukraine. Brent crude oil prices rose above USD 120 per barrel, reaching their highest level since 2008. As a result, many airlines in Europe and the Middle East reduced their long-haul cargo operations. For a carrier like Malaysia Airlines Cargo, operating routes from KLIA to Amsterdam or Frankfurt, which take around 12 to 13 hours, higher fuel price can significantly increase operating costs. If the route becomes less profitable, the airline may reduce flights from 5 times a week to only 3. That represents a 40% reduction in capacity on that route due to fuel costs alone. Next slide. So moving on to our third variable, which is fleet availability rate. This is a supply side factor and it has a positive relationship with air freight capacity. The higher the number of aircraft that are available and ready for service, the more cargo capacity an airline can provide. So this variable is especially important because it acts as physical limit. Even if demand is strong and fuel prices are reasonable, airline cannot operate aircraft that are grounded or maintenance, inspections, or repairs. Our examples involve Boeing 747, 400 freighter fleet affected by an FAA airworthiness directive requiring urgent engine inspections. Due to delays in inspections and maintenance processes, only 2 aircraft could be cleared each week. Within a short period, fleet availability fell from 85% to below 50%, forcing routes to be reduced from three weekly services to only one. This variable also reflects longer-term industry challenges, such as aircraft delivery delays from Boeing and Airbus during 2023 and 2024. In many cases, airlines were unable to increase capacity even when market demand was growing strongly. I'll now pass it over to Shami to conclude the presentation.
Okay, thank you, Arisa. So we look at each variable individually, but the real power of multiple regression is in how all three work together at the same time. Consider this. Global trade volume is surging, maybe driven by semiconductor export from Malaysia and Vietnam to Europe. On its own, that's a signal for airline to expand aggressively. But if fuel prices are also rising due to geopolitical tensions, each additional flight become more expensive to operate. The airline may still expand, but at a slower pace. Now at fleet constraint, suppose two of the airline five freighter are in C-check maintenance for 6 weeks. Suddenly, even with strong demand and manageable fuel costs, the airline cannot physically add capacity. Fleet availability becomes the binding constraint. This is exactly why multiple regression is more useful than looking at any single factor. Each variable on its own tell parts of the story, but only together do they reflect what's actually happened in the market. So the conclusion, air freight capacity is the result of three simultaneous forces. Beta 1 global trade volume set the demand foundation. Without sufficient cargo, there's no reason to deploy capacity. Beta 2 fuel price index acts as a cost regulator. When price rise, airline pull back, reducing what available in the market. And for beta 3, fleet availability rate creates the operational ceiling. It determines how much capacity can actually be delivered regardless of what demand and cost condition looks like. Together, these three variables from a robust and practically grounded regression model for Malaysia specifically as a key player in global semiconductor, pharmaceutical, and perishable supply chains. The ability to forecast air freight capacity reliable is critical, both for airline operating at KLIA and for planners managing cargo infrastructure. We hope this presentation has given a clear picture of how these variables interact. Thank you very much. That's all from us.